Hi, I'm Stefan, and I'm the organizer and host of the emBO++, the next level conference for embedded software developers. The talk you're about to see is about dependency hells and how to mitigate them with Git, CMake, and a shell script. It was given by Markus Werle from DuckTrain.io at the emBO 2021. And thanks to Volkswagen Infotainment, you can check this talk out for free.
Many thanks for attending this talk at this evening. May I just ask you to raise your hands to see if the sound is okay for you? Thank you. Okay, so the title slide shows a cup of coffee, and this is an original emBO cup of coffee, a cappuccino that was served to me on the very first morning on my very first emBO conference. And the guy who made it had the attitude to really bring it to perfection. And this brought a smile to my face and to everyone else who was served this way. And I put it here because I just want to say how much I miss it to see you in person. And at the same time, I'm really impressed by the preparation of this conference, and would like to thank the whole emBO++ team for their preparation and for the idea to put this in such an immersive environment. And yeah, it's cool, and I really love it. And that's the way how it should go. Yeah, not give up if something is not as planned, and still go on. Thank you for your preparation. And thank you for giving me the chance to talk today. I work at DuckTrain, a company that creates a bicycle trailer that is semi-autonomous. And of course, you can imagine that we also have a little bit to do with software, but also the hardware and the electronics and electrics of this vehicle give us a lot of headache, such that software development is not our pain point at the moment, at least in my perspective. Okay, the talk and its accompanying source code is open source. If you're visually impaired, you can directly download it from my account on GitHub, which is Dextrosi, is my GitHub handle, but written with AI instead of the first E. Saying goodbye to Dependency Hell. And the solution that I present in this talk is also available in the repository CMake utilities. I took over some code that was under MIT license for the talk source code, and also my own code is published under the MIT license. I added some of the photos that I made during the past years, and I put them on under the Creative Commons share alike license. So feel free to reuse them for your own talks, or change them, or whatever you like to do with them. I want to prepend my talk with a disclaimer. I don't think that this is the only solution that is possible. It's a solution proposal. Maybe it's not even the perfect solution. There might be other ways to do all this that I'm not aware of yet, or that I missed something. I give this talk nonetheless because I think this is my chance to get some feedback. It's your chance to maybe learn something, or maybe find out that you are even in a better position. Yeah, and you feel invited to give me some feedback after the talk, and to derive and make it even better, or present your solution as an answer to this talk. I would like to introduce Dependency Hell, talking about a real-world example. At my former employer, I was working on a system that had like approximately 300 to 400 libraries. Every little aspect was put in its own library, and we had 50 to 60 tools that were built on top of those libraries. Those were customized special tools for the automotive sector, for customers who wanted to only pay for what they really needed. So we created a tool by configuration system where you can have an arbitrary number of dependencies. The libraries contain the functionality that was requested, like reading and writing to an Excel sheet or reading measurement data from different formats, et cetera, et cetera. And so maybe you are in a similar situation that you have several tools and you have distributed among your company people who work on libraries, legacy code, whatever you have in your hands, and you have to deal with it every day. Find out how to bring all this together. Yes, and for this talk, I had to give example names to all the tools and libraries, and it took me quite some time to come up with something, because naming things and cache invalidation are the two most hard things in computer science. And so I came up with tool_1 and tool_2, and the libraries are numbered A, B, C. I called them lib underscore whatever, which is not a good practice in general. This is only to highlight it in this presentation. Normally, you shouldn't prepend anything with the name lib. Otherwise, you get a lib in your artifacts that are generated by the make system. Also, on every conference, there's one guy who thinks that he can mix up technical discussion and political discussions. And unfortunately, this is the case here too. So we have to cope with the situation that there's one library that doesn't follow the naming scheme as far. And yeah, but it is like it is. And renaming things will give us a lot of work. And therefore, let's keep it like it is. I want to introduce one dependency hell that I had to work with for several years, and that is Git Submodules. I made an investigation, skimmed the internet for hints which system would be the best to work with the dependencies, and this is what Google told me, that Git Submodules might be a good idea. And what I can say now is that you need very strong machines, and therefore I put some photos here. The right-hand side shows a photo of one of the largest machines that is available on Earth, and it's 60 kilometers from here where I'm located. It's digging the biggest hole in the world, and yeah, trying to find some coal to contribute to our global warming effect. Yes, and we have quite some quarrel about these machines, but they are fascinating anyway. So technical and political things don't go hand in hand all the time. So dependency hell with Git Submodules. Let's have this prepared. We have a tool. We take tool number 1, and we add the library A and library B as submodules. And we can do this with the git submodule add command, and we indicate which branch we want to use. In this case, the branch is master Yoda. This is the name came up when we had to distinguish ourselves from those who want to support slavery, and therefore we had to rename our master branches. For the talk, I decided to call them master Yoda, but if you are in the old system, it's the very same thing as master or main. But some names are difficult to use today. Yeah, that's my configuration here. And now, once I've done this, I get, and I call git status, I get some information of what has changed. And the interesting thing here is that Git reports that there's a new file, which is .git modules. And I think that is, yeah, a very clear thing. There, in this file, there's the configuration, but it also indicates that there are 2 new files, but those files are directories. never mind, we can commit this and push it, and oh, I pushed to and committed to master Yoda here. Forget about this. If we look at Git modules at the file, we see that everything is in it as we wanted it to be, the path where we want the library to reside. I like clean top-level directories. Therefore, I created a subdirectory third party, and all the dependencies are in this one. You might do it in another way. We could have them all directly in lib A, lib B. That doesn't matter. That's only a matter of taste, I think. And then you give the URL to the dependency and the branch or tag or version that you want to use. And that's fine here. So this part, I think, is OK. Now we do the very same thing for tool number 2, and we can skip quickly over this slide. It's only different. The only difference is that this one depends from lib A and lib C and no longer lib B. Then there is another dependency, and that is a dependency for lib B and lib C. They both depend on lib3assange. And one of them uses the branch WikiLeaks, and the other one uses the branch Belmarsh. And this is OK in this situation, I think, because we have some, they are submodules for different tools. So the weird linker errors that you could have if you include different versions of the same library might not appear here, or will not appear in this specific situation. But we have to be careful about this if we do dependency management, that everyone uses the right thing, and maybe this a solution can help. OK, so if we have a colleague who will use our tool now, and he clones the tool on his hard disk, then we have to indicate to him that he runs git submodule update, blah, 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 blah. I cannot always remember all those command line arguments. So I have written them down in some file in our GitHub repository to copy and paste them from there, or I put them in the README of the repository. And now there's the first surprise that I stumbled upon when using Git submodules, and that is I requested a certain branch to be checked out, and what is checked out is a specific commit, I think namely the latest commit in that branch. And this is a little bit weird because what it turns out that this is a detached state, and OK, this was new to me. Let's see how we come out of this situation. Here again, the summary of our dependency hell. So far, it's clear. We have a structure, and in real-world situations, the depth of this dependency tree can be quite large, and there might be also a large number of libraries, depending on the basic decisions that you take in your company, how much you persuade people to follow a separation of concerns approach. And we had a problem with Git submodules, and it nearly killed us. We used RxCpp. And if you clone that repository, you have 66 megabytes of disk space gone. And we had approximately 20 different repositories that had RxCpp as a dependency, and they were all dependencies of the tool. And it turned out that the modules update run took 1 hour in the workshop where the Wi-Fi was not perfect, just because Git cloned the very same repository several times. I think this is a quality of implementation issue, and it could be mitigated. I think this is only something that that takes one clever guy to fix, or a clever girl. Yeah, but maybe we don't need even to fix Git submodules because we can get rid of them. So this is in Cornwall, and like we did there, we just walked through that door and accessed the point behind this door. Let's enter the hell. So everything is set up and we start to code, and this is illustrated here by an example that in the sub dependency libfree assange, I will change some code because I have to. And if I run git status now, I get a message that something else changed. For me, this is also surprising because it's obvious that Git submodules understand, or Git understands that we are using, we changed a file in libfree assange, yet it indicates the change only to be one dependency level below the top level. Not sure whether this is a good idea or what is the advantage of saying this. Nonetheless, we can give it a try and add the changed file because we know what we changed. And okay, we cannot do this on the top level. I think this is also okay, a reasonable check. We are not in the library directory itself. Separation of concerns here. For some people, it turned out, at least in former teams that I had, it was counterintuitive to them. So maybe if you think about a system that does this, it could be smoother to use, have a better user experience. Nonetheless, we can switch to that directory, add the README and commit it, and oh no. When we push, we get the message that I forgot. Sorry, I told you before, but I forgot it already again. And this is what happens all day during work. We are in a detached state, so we cannot push anything in a detached state. I wonder if we could add a warning when we call git add readme, just for giving an indication that yeah, it's the path that we're going is already doomed. Okay, so I think it's getting already complicated enough. I'm not happy with Git submodules at this point. I definitely told the system that I want a specific branch, and this is not what I get. And now we are in a hurry. We have to fix things, and we thought we had a good and automatic system. And now the boss tells us that the deadline was shortened from 3 years of work to 2 years of work. And we have to hurry. And what we do when we're in a hurry, we become inefficient. We go by hand. So let's reset what we have done. We check out the correct branch. We add the thing, commit it, and push it. And yeah, then we go up one level from libfree assange to library B and perform a git status just to be sure that nothing is wrong here. And there we see that now in library B, we get the indication that something has changed in the dependency. That's not new to us. We changed something on the branch, and that is okay for us because we said to library B, you take the branch, and hopefully always the latest and greatest version of this one. So any attempt to do a git update, submodule update or whatever, nothing helps. We get this. And now what we have to do is we have to practice yoga with Adrienne or some other one who helps us, because we need a deep breath now for what is before us, because now add again this change and commit. Oh no, again the whole shit. Okay, reset. We check out which branch should we use to commit this change. It's not so clear. Okay, I take master Yoda here. I check if somebody else has made some changes outside. Glad nobody worked on this besides me. And now I add this and then commit it and I push it. Okay, if in library B we had a change, then maybe in tool_1 we have to do the same thing. And yeah, but here with the branch, I'm pretty sure the guy who maintains this enforced that we use the GitHub workflow. So we need a branch. So let's create a branch, and it's a dummy branch because it's a branch for a change that changes nothing. And we push an upstream that we get the same branch on the server, and then we add it, and we commit it, and we push it. And this is 10 commands to reflect the change in a sub system. And this scales with order of n with the number of nesting levels that I have in my dependencies. And this is the point where I already I'm deeply concerned whether this is the right track to go. First of all, that submodules are bound to commits rather than branches was the one thing that I was really surprised and thought, nah, it's not what I would have expected. And now in a deeply nested structure, one little update deep down in the structure taints the whole tree, and changes are no longer local. And what I think is also not really nice here is that, in my opinion, git add and commit are abused for changes that are changes of the database. Besides the file that I edited, no other file in the whole tree changed. Nonetheless, I have to add and commit. And this is something that is counterintuitive. It's not consistent with the rest of Git, and I'm not happy with that one. And I wonder if this is one of the reasons why many companies decide to use a large monolith Git repo and work with that one, and then lose the ability to have configuration management or whatever else, or find other ways to deal with this, write their own Python scripts to bring all things together or whatever. Yeah, I'm not happy with the situation that is in front of me. The question is, do I want to waste further breath to commit empty stuff to my server? And now I want to talk about something completely different, and that is CMake. I searched for a background image for this slide, and when I saw this photo that I made in Cornwall, I decided I have to take it. And it's a double twist here. First of all, most people think that probably CMake should be extinct in some way. It's old, and it's sometimes has some features or buttons that we have to press that feel like this is outdated. And on the other hand, there are people who took the genetic code of all this and did what we can see in the movie Jurassic Park and Jurassic World, namely revitalize this, and not only revitalize this, but also make it better and more aggressive and more powerful. And if we look back at the last 5 years, what happened to CMake is that people took the hard job to fix a lot of the issues that were there before. And that is really something that I'm impressed of, to see that the major critique points that you could read in any forum, where you can see where people get lost with CMake in past decades, they are gone with the new features that are available in CMake. And if you know that those new features are there. And therefore, I want to give some advice. Never ever follow any advice that is older than 3 months. Okay, in general, this advice won't age well, but I think for CMake, that is really true. There's so many changes during the past years that if you run into a forum and you read something that is old, it might well be that this is no longer the way to go. So searching the internet to find out how CMake works is not always a good idea. Maybe it's even not a good idea to even try to find out how CMake works at all. And you can read about this in Isabel Muerte's blog, Everything You Never Wanted to Know About CMake. Yeah, maybe read a book. I have a proposal for you. Craig Scott, Professional CMake, A Practical Guide. And I will not get any money for this, but I have to do this today and tell you that I'm so grateful that Craig took the time to write this book. I wish this book had been written 2 years earlier, because for me it was the first 2/3 of the book was confirmation of what I have found out the hard way. But also Craig gives talks on YouTube, and thank you, Craig, for what you do. Because this is something that will help a lot of people to get around build systems and all the trouble that you may have. Thank you. So how to deal with dependencies in CMake? In CMake, there's a feature that is called FetchContent. And FetchContent performs during the configuration step. There were other features in CMake that would run at build time, but now you have the possibility to use FetchContent and then do some normal CMake stuff on the content that you have fetched before you start with the build process. So this unfolds many of the headaches that you had before. And FetchContent has a 2-step approach, which is a declaration first. So you say what you want to have, you give it a name, you tell FetchContent where to find the code, and you tell FetchContent which tag or branch or whatever you want to use. And once this is done, then a lot of variables are set. Of course, it's CMake, so it's global variables that are set. But okay, in this case, it's what you really want to have. And then with FetchContent make available, generate what is necessary to have this library built in your project. This only works if your library is configured in the way how CMake projects should be configured. Therefore, I point again to the book that I mentioned earlier. And the second step is equivalent to just reading some variables, checking if one of the variables is available or not, and then indicate by setting global variables that you're going to fix the not yet populated library, and then you call add subdirectory. So make sure that all your projects can be used with add subdirectory. But this is it. If you have to do some special case, and since we are on a conference where people deal with a lot of hardware, where things are not as easy as in the rest of the world, you always have to do something special. That's at least what I learned from you. And I don't believe you, but that doesn't matter. Of course, it's true what you tell me. So here's your chance. Add your own stuff here. And this is how you can use FetchContent. Again, a summary of the key features of FetchContent. We have the possibility to fetch stuff from Git repositories. We have the possibility to fetch it from a web server via URL, even checking the checksum. And we can fetch content from a source directory on our hard disk. I will use this feature for my proposal. There's a little surprise here. Stay tuned. And we're going to see how to use this for our solution. There's one very important key feature of fetch content, and that is the first call to fetch content declare wins. This means you can override dependency settings in libraries that you include. Of course, this only works if the libraries you include also use fetch content, but this is the basic idea of fetch content, that your whole hierarchy tree that you have control of uses fetch content, because now if library B wants to use a certain version of libfreeassange, I can override this when I include it in tool number 1. So I can change the branch or release version, if compatible, of course. If the thing does not build, then I have to do something. I can change the source location. So maybe the source is not easy to access, or I have to have a 2-stage server to a firewall or whatever, depending on what safety level my software development team has to achieve. And you can even redirect to a completely different library. Just give it the same name. If its interface is compatible, we can rip off a dependency of one of our dependencies and replace it with another one. So this is a very important feature, and we have to use it in the solution that I present. So here's my proposal in a nutshell. We create a file, and we have to give it a name, one of the 2 major problems in software development. So I came up with dependencies.txt. I put it in the top level of my tool directory, tool repository, and I add all the stuff that I want to use. I want to use lib-A and lib-B, and I know that they also have a dependency to libfreeassange, and now I unfold the tree and flatten it and put everything in one bag on the same level. So I say every dependency and subtype dependency is mentioned here. And also I have some tools that I like, that I want to add in my system from other developers outside there. Thank you for your hard work, for Catch2 and for libformat. And yeah, that's it. I put all the dependencies in this file, and then I use FetchContent to download the solution that I want to present in this talk. And I make it available. And once it is made available, I have a script function, a CMake script function, which is called FetchContent Dependencies, to which I can pass an argument for a file that contains all the dependencies. That's the one we saw on the slide before this one. And also mention a workspace. So this is the directory structure that I have in a regular CMake project. And if I run the normal 3 steps to have CMake configure everything for a build, I come up with all the dependencies that are mentioned in the dependencies.txt file are copied from the internet and put in a subdirectory of build, which has also a very interesting name, _deps. So someone had the same idea what it is. It's a dependency. And this is where FetchContent puts all its stuff. And it's interesting to see they organize it a little bit different than others would do. So they have a build directory, a sub-build directory, and a source directory, which contains the original source code. So, OK, we have it there, and so this means for all of my dependencies, I have 3 directories containing stuff that is either generated during the build phase or put there during the configuration phase, with all the make files and CMake files that I probably need. And the question is now, if I have this situation, how do I debug and edit the code? So if I have a problem, it might well be that all the distributed code in my code base distributed among different libraries and dependencies has to be under my control. I have to edit code to find out where the bug is. I have to chase the bug. I have to find out who's the culprit of the problem that I have. So it would be nice to clone all the dependencies to a certain place on my disk and edit it there and use it in the build somewhere. And so I need something that transfers the code that is at a certain place on my disk to the build directory. And my proposal is to have a workspace, finding good names again. So WS came to my mind. And since Git cannot put directories under version control, I add a dummy file that probably gives someone an indicator why I need it. And then I add this workspace to the Git ignore, so nothing inside it can confuse Git. And then I clone all my dependencies into this workspace, again, without any recursion. And now I have to ensure that CMake will fetch from this workspace and will track code changes in that workspace. And it turns out that this is quite easy. So first I have to clone all those repositories. And since I'm lazy, I write a shell script to do the repetitive tasks. And the script can be started. It's called setup sh, because it's the first thing that I do after cloning. And this one grabs all the information that is in dependencies.txt that already CMake used, and will clone all the stuff into the workspace. Here they are. And also the recursive dependencies, deep down in the dependency tree, are on the same level. So I have every library that is participating in the build process of this tool on the same layer, side by side, and I can open it in Visual Studio Code and work.
Wir sind hier in einem kleineren Grossraumbüro.
Bei den Leitern habe ich die Freiheit, dass ich, wenn ich anfange und wenn ich höre mit dem Arbeiten, eigentlich selber einteilen kann.
Overall, how I will do it, it's just up to me, and they give me a lot of freedom.
Für mich ist die Faszination, mit anderen Leuten einen kreativen Moment zu generieren.
Great colleagues, great environment, basically.
It's really nice here, and I don't have any issues living here.
Am meisten schätze ich in den Like Geosystems, dass wir ein sehr junges Team sind, sowie dass ich auch meine Arbeitszeit in einem gewissen Raum selber bestimmen kann.
And I could merge my life hobby with my office job.
Das Besondere an der Like Geosystem ist sicher die Kultur und die Dynamik, die es gibt in dem Team. Es ist jeden Tag ein bisschen anders.
We have good organization which will help you to get used to the company in the first couple of months especially.
Das ist sehr interessant und ja, macht mir Spaß.
With it, check all the code, switch to another branch, do things as I like. And now, if I run the CMake scripts that I've written during the CMake configure step, something interesting happens, and this is what you get is a build directory that still contains the directory _debs, but now it only contains a build and a sub-build directory, no longer a source directory. And this is due to FetchContent declare something source dir and path to a directory, because FetchContent doesn't fetch if we use a source directory. What it does is it generates a reference to the original data that is stored in the workspace. And this is nice because what I get now is that the exact code that I'm editing is also the paths to the files that I'm editing is the very same that I find in the debug information. So if I have an IDE where I can jump to the specific source code file, that comes to my rescue. And also if I do what I do very often, remove everything that is in the build directory, that's not such an issue. I can reconfigure and it will simply put some pointers here and there. So again, FetchContent declare with source dir as argument does not fetch much further. And as far as I can see, this is the most efficient usage of hard disk space, because the next step would be to compress everything. But any code that participates in this build process is stored exactly once on the hard disk. And the nice thing with this solution is that CMake works with or without any clones in workspace. So if you decide not to run setup, doesn't matter. CMake will work as it did before, because the script does nothing else than what you would do by hand, namely fetch content everything. And at the same time, CMake and the setup script, they are completely orthogonal, but they share common information in the dependencies.txt file. And so this is a small solution, but it serves what I have to do in my daily work. So let's take a look at the code. It's only 3 slides because I stripped out the not so interesting parts. Although CMake is not the perfect programming language from a design perspective, there are some utilities to have macros with command line parsing, and CMake parse arguments comes to our rescue here to have 2 arguments, file name and workspace. And also the command file helps me to read the data in the dependencies file to line by line into an array and use it. And so for each dependency, I step through the file and I remove all the hacky string parsing stuff here. What we do is we determine if there is a directory below WS in the workspace that has the very same name as the one that we gave in the configuration file. And if it exists, what we do is we call FetchContent declare with the source dir argument. And otherwise, we don't care, and we call FetchContent declare with the Git repository name as done before. It is very important that we first declare all dependencies before populating them. Otherwise, dependencies might steal the decision over which version we use. So this first loop that we do is only doing the declaration for FetchContent. And once we have run through all of them and decided which one we want to use, all other dependencies that are below, when they are called, get already the indication that we decided for them what version or what source code should be used. Now we come to the populate step. For each dependency, hacky string parsing, and then we do what I presented earlier. We do the get properties. We do a to lower for the names. Otherwise, we get into some really weird problems. I think you should give your libraries names that are lowercase too. I think it's a bug in my slides. Check the documentation of CMake. There was some issue with lowercase and uppercase and mixed case. If it's not yet distributed and known to everyone else, then we run the FetchContent populate command and add the subdirectory to our build system. And here you see my first hack, and I'm not happy with that one in this script. The first hack in this script, not my first hack in general. We have to deal with additional features that are available within Catch that are not available automatically, but are optional. This means that I have to add a certain path within the Catch directory and then run an include command such that some of the CMake commands that are available for the Catch library are available within my build system. And I want them, and so the only way I found to do it automatically was to check the name. So this is here coding by convention, and I don't like it. Should be more robust. Maybe we should add another configuration file. I don't know. I'm not happy with that solution, and I don't have a better solution at the same time. Yeah, that's the CMake. And I just wanted to indicate to you that our setup script has some more features. So if you run the normal setup.sh -h or -- help, you will get some indicating what this tool can do. So you can run it anytime without any destruction of your code. So running setup.sh without any command arguments will only check what is on your disk. And it will show you that one of your dependencies in the workspace is not up to date. And it will show you if some of the code that you have written is not yet committed or in a state that needs to be pushed or whatever. So no way to forget anything, because you simply run the script and you get what you want. It also has, you get all the information. It has some command line arguments that you can switch to specific branches. So if one or more dependencies of your code have a certain branch name used in their repository, you can check them out all at once. So if you have a problem, you probably have a branch that is called bug chaser. You know which libraries might be the culprits. So you generate that branch, and then you run setup.sh with the branch command, and then it will switch all those to this branch to play around with this. And that is the complete solution, and you can check out this code and use it and enjoy it. So that's the summary. FetchContent is a feature that really turns out to be a very flexible tool for dependency management, and you can have it all. All code is visible to the IDE and the debugger. You have a minimum of copy operations on the hard disk and via internet. Once you have run setup.sh, if you have not forgotten any of your dependencies or the sub-dependencies, you can detach from the internet and delete your build directory as often as you need. And everything is at its place and will work fine. So if you're programming in the train in Germany, we are very sorry for our internet connections here in Germany, then you are happy with that solution because you can let the others stream the Netflix stuff while you are working on your career. Yes, and I think that's exactly the level of control over the dependency tree and the configuration management that I wanted to have. If you have further ideas, I'm eager to learn about them. Thank you for your attention. And now let's see if I can read the chat and get some questions. Still a problem here. Did you check out Conan before beginning this? Honestly, no. I was thinking about a solution that was working with source code, and I didn't want to leave the CMake system or have some other tools beside this. So this is why I came up with this solution. I was trying to find something that only uses the CMake, because CMake is what is there anyway. There is another one. So a lot of people mentioning Conan. So you would automatically get updates on the defined branch of your dependency. Sound a little bit scary to me if you are close to the release. No, I'm not getting the updates automatically. I have to trigger this. So I only can check if there are updates. So it really depends on how you want to deal with this in the company. In our case, the main branch is the one that contains all the truth that has to go into the release. So it's the GitHub workflow. We don't have a release branch, but we have like things coming together in the master branch or the main branch. And yeah, that's why it's not such a problem for us. But the script is really non-destructive. Only if you give it a certain argument, it will start to change something on your hard disk. But it will already fetch the stuff, so you can easily switch. So you wrote a bash program. Is all of the things put into CMake libraries, or do you have to copy paste it into a new project? First of all, why did I use bash? Because I found out that Microsoft delivers Git bash together with with Git, or not only Microsoft, but Git delivers this. So everyone who uses Git on Windows has the bash already on the machine, so there's no extra dependency. You could, of course, write a Python program, and this is what my colleagues are nudging me to. They say Python is also a good thing. The CMake library that I'm using is, I do not have to copy it. I fetch it via FetchContent. So I use FetchContent to fetch something that will fetch other stuff for me. Yeah, so I have to call it once manually, and then I can use it later on. Any other questions? Stick with bash or reduce further and script it just in CMake. Yes, you're welcome. Try it. might be worth it, because we only copy a little bit, so the functionality is there in CMake. Was more or less me not knowing about how to deal with command line arguments in CMake, and didn't want to read another 2 weeks of manuals. Okay, there's another solution, tribits.org, that is mentioned here from Tobias. Thank you for that. I will take a look at it. The additions to your CMake list.txt that you showed, do you need to put that into each new project? Or this is something that I answered just now, I think. Maybe it came here twice. Do you need to put that into each new project, or does FetchContent also put it into your CMake list? I use FetchContent to fetch the CMake file that contains the function, and this will be put into the dependency folder of the build directory, and then I can use that function there to do the rest. So I don't have to copy anything manually. I only need this 3-liner in the CMake list.file, and you can use this. And you can see this. This is why I created those 2 organizations on GitHub, the DepHell and DepHeaven organization. So I have an example library there with all the CMake files as an example. So you can simply copy paste this as a starter to try the solution. So any other question? Seems not to be the case. Thank you very much.
If you found this video informative, make sure to subscribe our channel. Click the thumbs up if you liked it, or leave us a comment on what we could improve. If you are looking for a job in the embedded industry, or you've got one to offer, drop us a mail to jobs@embo.io. That's jobs@embo.io. And we'll make sure that you match up. My name is Stefan Bückelmann, and as long as you keep watching, we'll keep covering the internals of the embedded industry.